Thank you, everyone, for coming to hear my talk about user provisioning at scale. I'm going to talk about a package that I wrote over the past few years for my current company to help with provisioning users from identity providers. So some of the bigger identity providers like Okta or OneLogin, Azure AD, they have a protocol in place called SCIM2, which allows for updates on their end to be propagated down into other systems. For example, your application and our application. So jumping in, there we go. Just to be clear what this problem is solving. Putting yourself in the position of a admin at one of these larger companies. Pick your favorite large company. Let's see, Google or Spotify, something like that. You've got hundreds of thousands of hundreds of thousands of employees potentially. Siemens is another great example. You want to add all of those users to a new system. You want to give them access to a new application. Let's make an example of that application, and let's say it's Spotify, or let's say it's G Suite or something like that. You want to give them access to that tool, and you want their information to be automatically pushed to that system, right? You really don't want to do this via some of the old-time alternatives like CSV imports, where you have every user on a different line. One, that'd be one big CSV file. Two, would be quite manual to fix any tweaks to the CSV file. And anytime there's a change to one of those 100,000 users, you'd have to do another CSV import, right? Obviously, 100,000 users is the extreme in terms of company size, but this problem is still a pain for companies of size above 20, and they don't like going in and managing users individually. So having a protocol like this that allows for mass user updates, mass user creation, and mass user deactivation was certainly a need. It's been around for a long time, and this is just one of the more recent protocols to address this issue. Just to be clear, this talk is about a bunch of code that is written to abstract away boilerplate code within the Django ecosystem. This is not about how to parallelize the provisioning of a set of users across a set of users or machines, not users, but machines in your application. So that would be a cool talk. This just happens to not be that talk. So what existed before SCIM? There was a number of different open standards. Some of you may remember the vCard standard, where you'll have pretty much a plain text file sent from one application to another. And one vCard would start with begin vCard, and then it would say the version information, and then it would say N for your full name or display name, if you will. And then your first name, and you'd have this delimiter of a colon in between the key for the attribute on a user, and then the value would be after your delimiter. There was a number of these. The industry didn't really consolidate around any one of them. They were all better or worse in different circumstances. And that's what, whoops, I think I clicked on, oh yeah, this was a link to allow you to jump to that if you wanted to. And it opened up a browser in my screen. But moving on, in 2015, SCIM 2.0 came around. So SCIM, in its 1.0 incarnation, had been around for a little bit before that, earlier 2010s. And then SCIM 2.0 came around in 2015, that really solidified what was working well and cleaned up some of the things that weren't working so well in the SCIM 1.1 standard. Now we have a very nicely shaped JSON scheme, as you can see in this box over to the right of the slide, where the schemas that will be used to define the information within the blob that was sent from identity provider to service provider. In our example before, from something like Okta or Google to something like Spotify or whatever whatever email tool you're using. And And again, yeah, nice JSON schema. The meta information, so schema about the schema, is encapsulated within the information sent. You can already see that it's pretty easy to read what keys correspond to what information. It's not as cryptic as, say, a V card. So name is an object, and this object is further subdivided down to, well, what is the formatted name and what is the family name? What's your given name, right? So this just makes it easier for a human to look at the code and to debug it as it's coming through, as these messages are coming through. So in 2016, my company 15Five noticed the need for this and noticed a need for our ability to support this standard. There wasn't a strong django-scim 2.0 library out there at the time. In fact, there wasn't any from what I could tell. There was a pretty strong schema 1.1 library out there, or standard 1.1 library out there. But it was missing some of the stuff that we really wanted to use from 2.0. And it didn't support all of the different HTTP verbs that you could have. So posting and posting and getting were pretty well supported. But some of the other verbs were left out. And we really wanted a fully featured library, for at least for what we needed to do, which was full lifecycle user management in our system. So that's when I said, let me take on this project. I'd really like to take on building out this library from scratch and trying to make it as open source from the beginning as possible. So the way I designed it was that we'd have a standard Django app. As you can see, the templates, or the let's say, how do I say this? The tree structure of the application is over on the right-hand side. It's a pretty standard Django tree structure. But it has a few extra files or modules to the application. For example, adapters and filters aren't really standard files within your average Django application. And what it does is it attempts to implement the generic views so that you don't have to. And what you implement instead as a user of this library is the adapters. And the adapters wrap a particular object in your system or a particular model. And to be specific, it will wrap two models in your application, your overall Django project. It'll wrap your user model, which almost every Django project has one, unless you've kind of stripped out the admin interface, and also the group model, which is far less used in my experience, but still there. It comes packaged with the Django admin application. There is some middleware built into this library, but it's only to wrap the views that are used for SCIM, so that you can do better debugging and better logging, and a little bit of rejection away, properly formatted rejection of SCIM requests if you haven't been properly authenticated. It does not do authentication. That is left for a different library. So if you're thinking about, like, well, how does SCIM handle authentication? It has defined standards for how to handle authentication, such as like OAuth bearer token, but that's left up to another library if you want it. If you want to lean on another library to do that, you have to for this library. And because of that, any middleware for SCIM has to be after your authentication middleware in the Django overall project middleware. Okay, so diving down to see what I mean by the views kind of implement the boilerplate for you. This is a pretty standard Django-scim2 views view. You'll notice it inherits from object. I can at this point probably get rid of that because we're almost fully ported over to 3 and it doesn't really support 2 anymore. And in fact, I think we use F strings now, so it definitely doesn't support Python 2 anymore. But it also doesn't inherit from the standard Django view because we leave that for a later class that encapsulates all these other helper or mix-in classes. So again, focusing back on this post view, it handles post requests, And what it does is it grabs a model class, and it grabs this model class by looking up a model class attribute on the class view and instantiates that with no args. And then you have a kind of a blank object to deal with. And you pass that blank object to a SCIM adapter. And this SCIM adapter is what handles the translation of SCIM changes to your object to whatever your local or native attribute names are. And you'll see a little bit more of what I mean in just a bit. And load body, excuse me, not load body, but from dict takes the body of the request, the SCIM payload, that JSON object, and converts and does all that conversion for you. Finally, your SCIM object that is instantiated from passing an object to the SCIM adapter is saved, and that can trigger a save or whatever you want to do with the SCIM object. Let's take a look at a lower portion of the views file. The users view, which does inherit from a Django view, so it implements a lot of that standard view architecture that Django provides, is bundled into SCIM view. So SCIM view inherits from a Django view, just to be clear. And you can define your model class getter and your SCIM adapter getter, so you can configure whatever you want, or you can define your adapter, so you can configure how load dict works, how validate dict works, how load body works, those things, by defining these functions and overriding them in the SCIM library configuration. So that kind of brings us to this adapters file and where we do this overriding, or where we implement the from dict method. The from dict method, again, is on an adapter, and the adapter is what's passed that blank object during a creation request, say a post request. It'll be passed a full user object or a full group object if it's during some other mutating request rather than a simple creation request. So like a put or a patch, those would be mutating requests rather than creation requests. Here, after we've performed your standard, let me rephrase. Here in this from dict method, one of the first operations I do is I let any of the boilerplate code from the library do what it needs to do with this super call, right? So I pass the dictionary, which is now a Python object or a Python dictionary, but it's the same shape and same schema effectively as the JSON object that we got. We pass that on to do any handling that we want the library to do. And then we pull whatever we want from that dictionary. So say username or given name, family name, we can pull all of that and attach that onto our object as we see fit. This object that's in our system that will be saved to our database or our persistent storage is bundled up in this self.obj object. And again, that was passed in during our SCIM adapter call that we saw in a previous slide. So post and put calls are all handled with the from dict method. You implement everything that you want to take from the JSON object that comes through in the SCIM request. You take everything you want and you put it onto your user object in that from dict call, and then save is handled later. Patch requests have to be handled a little bit differently because their object that comes in is not it's not an object that kind of maps cleanly to the attributes that would be on a standard user object in a Django project. Instead, the patch requests are JSON objects that come through with a schema of patch op, and then an array that is keyed by operations. So here I have operations as my key, and then you can see a JSON array follows. And within each, or that array contains a bunch of JSON objects itself. And each one of those objects has an opcode, something like add, replace, or delete, something like that. Remove is the official value for the opcode, not delete. And then you have values that will be used by that operation. So if it's an add operation, then you'll pass a value, and the value could be something like emails. And this will add the email to your user, right? So you couldn't use the same from dict method that you saw in a previous slide to cleanly parse out what's in this code or in this SCIM object and update your user. So I used a separate set of methods to do that. And these are patch handlers. So you have one for patch add, or excuse me, you have one for add ops, one for replace ops, and one for remove ops. Here we're looking at a handler for the replace op. And what it's passed is the path, which can be kind of complicated, and we're going to get to it in just a little bit. The value, which is this value blob we saw previously. And then the whole operation dict in case you wanted to use that. It gets a little bit hairy in here because there's a number of corner cases that we need to handle. Different IdPs send their SCIM blob in slightly different ways. And we've learned from trial and error at 15.5 what tends to work best across all of them. And so that's why you'll see a little bit of this nasty code, or at least unclear code where we check if value is not a dict, then let's make it a dict kind of operation. But if you look at the second half of this slide here on the right-hand side, you'll see that we iterate through all of these values in our individual operation, and we pretty much do the same updating on the object that we were doing in the from load or the from dict method that we saw before on a previous slide. You might be asking at this time, well, what is this path that's getting passed through this handler? That path is not present in this slide, but it is present in, let's see if I can find one. Nope. Okay, left it out. I should have included that, but let me explain what a path looks like. It looks like this. It looks like emails type equals work, oops, and value, da 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 da. And what it does is it specifies what users you want to perform this operation on. So perhaps, and although it wouldn't make sense because users usually have different email addresses, but what if you wanted to add the same email address to a bunch of different users? Or a better example, what if you wanted to add the same family name to a bunch of different users, right? Which we see down here at the end of this blob. That makes sense. A lot of people often have the same last name, and it's nice to do a bulk addition. But you need some way to filter down your users in your application. SQL is an often used way to select a bunch of users to operate on. So how do you take this path and convert it into, say, some SQL statement so that you could do a simple update call on all of those users at once? Well, I saw this as another opportunity to perhaps complicate things a little bit more by breaking this logic out into another library, but also to keep things relatively low complexity per library as the libraries move forward in their lives. So I decided to create another library, another open source library, to parse these paths that come through, because again, they can be very complex like this. So you're selecting all users that have a type of email labeled as work and a value that contains, that's what CO means here, contains @example.com, or has an instant messaging service. I think that's what IMS stands for, type XMPP. You get where this is going. And bundling that all into the other library just seemed added complication and bundling too much in one place. So broke it out into a library called SCIM2 filter parser. And what it is, it's my first fully fledged production working compiler. I took a great compiler course with David Beasley. I'm not getting paid by him to say this, but I enjoyed his class very much. And if you're interested in compiler building, I encourage you to look into his course as an option. And we built a compiler in Python. I took those skills and built a compiler to change these paths into SQL queries. And you're seeing it here executed. You're seeing my library executed with a command line tool here, sfp-query. But you can absolutely use it with an API built into the library, and that's what we do in django-scim2, is we call out to scim2 filter parser via scim2 filter parser's API. And what it'll do is it'll take a path like this, it'll convert it into a SQL call like that. Please note that SQL injection is avoided in the actual library. When you're using the command line tool, it's assumed that you're not using it in a production environment, so that's why you see these completely built queries. If you're using the API, the query is left open, or excuse me, the query is left open for you to include parameters separately in your SQL execute statements that you might make. This happens to not be an update call, but again, you can use your the API of this library to change it to be an update call as you wish. So we take the SQL that comes back from this library, we execute it, and then we know which users we need to update with those operations. We execute the operation, and then we hand back a response. So the full flow is a request comes into your Django project. Your Django project passes off those SCIM calls almost directly via an added entry into your URLs file, or your project root URLs file. The request is almost directly handed off to django-scim2. If django-scim2 can handle the request on its own without doing any scim to path parsing, then it does so and hands back a response. If it needs to do any parsing of paths, say because it was a patch call or it was a get query with a more complex path, then it passes that path off to scim2 filter parser to do that parsing. And we get back the parsed paths, and django-scim2 uses that to handle any operations or filtering down of users that needs to be done. Finally hands back your responses, and we're pretty proud of this. It's been in production now for going on a couple of years. And as far as the scim2 filter parser library, that's been in production for about a year now. And we've run into a number of bumps, run into a number of complaints from customers, but thankfully those have all helped us to make a much better, smoother library for our customers. So with that, that's all I have for you today. I think I have a little bit of time for any questions that anyone might have. Cool. Well, if, oh, I'm seeing something in chat. Let's see if it is, okay, great. Yeah, just got a thanks for sharing. So without further ado, I'll say thanks so much again for having me to Sammy Fung and the whole PyCon Hong Kong team. And hope you have a wonderful rest of your day. Thanks, everyone.